The universe could be shaped like a bizarre, twisted funhouse, ever since Albert Einstein showed that space and time could be dimpled, warped, and stretched out of shape like an old mattress in a cheap motel. Cosmologists have gazed up and pondered what kind of food our universe most closely resembles in terms of shape. Is it shaped like an infinite Pringle, bending up and out forever into eternity? Could it be a pizza? Perfectly flat if you ignore the bumps of galactic pepperoni and cheesy dark matter? Perhaps it's more like a spicy meatball, curving back until it meets itself on all sides, or just maybe it's more like a donut that forms closed loops in multiple dimensions. An international team of cosmologists who recently formed a group called the Compact Collaboration has analyzed the remaining glow of the Big Bang and concluded that nothing in its patterns rules out such a cosmic landscape. If it twists the right way, at least, because twisty cosmic donut isn't a bona fide mathematical term, the researchers use the term 3 torus to describe the mind-bending possibility of poking yourself in the back of the head with a stick some tens of billions of light-years in length no matter which way you face. Imagine another way: our universe could be one giant carnival funhouse, where instead of a series of mirrors, spacetime bends around in every direction, allowing you, in theory, to see your own back pockets if you squint hard enough. It's an alluring possibility that's been revisited over the years, and not just because of physicists' bias for gourmet desserts. Exotic shapes on a massive scale could direct us to physics on how our universe emerged from a seed of, well, somethingness. Roughly 13.8 billion years ago, everything we can see was crammed into an impossibly small space that science is yet to describe, requiring a mix of quantum physics and general relativity that we're yet to land upon. What can be described are the moments when space stretched and the material inside it cooled. At some point, the universe expanded enough for some of its electromagnetic radiation to avoid the dense crowds of electrons and congealing atomic nuclei. A fraction of those free photons have managed to avoid collisions ever since, happily humming along as expanding space has stretched the light into long, cool noodles of microwave radiation. This low-energy glow is called the cosmic microwave background. Mapping subtle variations in the CMB's glow can give us a rough idea of what the early moments of expansion look like. While this is handy for some models, the scale and patterns within the map depend largely on how space is shaped, leaving other theories open. If we're living inside a giant pizza, those fluctuations should all accurately reflect the same scale. Got a Pringle universe? Light might bend in a way that makes variations smaller than they appear. Meatball? The light might have ballooned. And if it's a donut? The universe would be topologically flat, like a pizza, only with repeating patterns that might point to phenomena that break radical new ground in our quest for understanding the origins of everything. Unfortunately, clear signs of these closed loops of space and time are yet to be seen in the CMB. Before you yell "case closed" and "where's my side of galactic garlic bread," members of the Compact Collaboration argue we shouldn't be quite so hasty. In their inaugural publication, the team argues that some exotically shaped universes based on the more twisted forms of a 3 torus are still compatible with the CMB, while the run-of-the-mill donut runs into problems at certain scales. We can't so easily dismiss versions of the torus that twist light in such a way that patterns distort but retain a correlation. Looking for those correlations might yet reveal exotic features of our universe's overall shape, perhaps with twists and curves that demand new physics to explain. Thank you very much for watching. Goodbye.